So we're now ready to talk about linear approximation of functions of two variables. Although one more thing I should have said about differentiability, which is that it's a fact that if fx, the partial derivative, fx and fy, are defined and continuous in a neighborhood of the point x0, y0, then f is differentiable at the point x0, y0. So in practice, if you want to prove that a function is differentiable, you're not going to have to go into that complicated definition that we saw. You just have to write down the partial derivatives and make sure they're continuous functions. Okay, so now what is linear approximation? So linear approximation says that if f is differentiable at a point x0, y0, then if we look at f of x0 plus delta x, y0 plus delta y, then this is approximately f of x0, y0 plus fx of x0, y0 times delta x plus fy of x0, y0 times delta y. Now, in the actual definition of differentiability, we know the left-hand side is equal to the right-hand side plus these epsilon1 and epsilon2 terms. But we know that these epsilon1 and epsilon2 terms are getting very small as when delta x and delta y are very small. So this is a good approximation when delta x and delta y are small. And geometrically what it's saying is, to approximate the value of f of x0 plus delta x, comma y0 plus delta y, we're going to pretend that the graph of f is actually equal to the tangent plane at the point x0, comma y0, comma f of x0, y0. And if the graph were equal to the tangent plane, then this would be inequality. And in general, there's some error which tells you how much the graph of f is curving away from its tangent plane. So let's do an example. So let's approximate the square root of 3.012 squared plus 3.997 squared. Okay, so let's let f of xy equal the square root of x squared plus y squared. And let's let x0, y0 be the point 3, comma 4. And then we know that f of x0, y0 equals 5. Now, we actually want to calculate f of 3.012, comma 3.997. So here delta x equals 0.012, and delta y equals minus 0.003. Important to not forget the minus sign. Okay, and so then the approximation is that f of 3.012, comma 3.997 is approximately f of 3,4 plus fx at 3,4 times 0.012 plus fy of 3,4 times minus 0.003. Okay, now when we calculate fx, fx is x over f. Right, because you get 2x over 2 square root of x squared plus y squared. And fy equals y over f. So we get that fx of 3, 4 equals 3/5, and fy of 3, 4 equals 4/5. So the result is that square root of 3.012 squared plus 3.997 squared is approximately 5 plus 3/5 times 0.012 plus 4/5 times minus 0.003, and when you worked it out, it comes out to be 5.0048. And if you compare with what a calculator says, the calculator gives us 5.004812,984. So we got 5 significant digits. That's pretty good.